Alright, mic is unmuted. Good morning, afternoon, evening, whatever time it is. This is the video to go over my code for the BuilderGame Lab 4 CpE 3020 VHDL designed with FPGAs. Monday, Wednesday, Friday. The 11 a.m. class. I almost said 10 a.m., but 11 a.m. Alright, moving onward with my code. The design. I do apologize if you hear any background noise. My headset, if there's no audio playing in it, then it will go to sleep and my mic will cut out. So to avoid that, I have a 10-hour video of a campfire playing in the background. I set the volume really low, but I think the audio might come into the video. Hopefully it doesn't. But other than that, if my explanation of my code lasts longer than 10 hours, then I'm screwed. But hopefully it doesn't. All right, moving on. So, just got my builder game, my name, the description, 2 inputs, and have the game set up around the 2 inputs left and right button. 2 players building a railroad, the LEDs, and it consists of multiple rounds. Each LED player turns on after the 8th one translates to 1 point gain for the round, and the first player to get 21 points wins the match, and their score flashes on the segments. If a player overlaps his railroad onto the other person, then the highest score for that round is given to the person who did not. Alright, so, we got our entity, we got the ports, clock, reset, the 2 buttons, LEDs, segments, and anodes. Got some constants active, count 100 megahertz for 1 second. I'll be using this in my 1 second timers, and the 25 megahertz, I'll be using that in my blanking timer. So after the person wins, their score will blink on and off every quarter second. And here I've got my state. Got the modes right here enabled when P1 bad press, P2 bad press, P1 good press, P2 good press, and not enabled. Current state or next state signals for the mode or for the state machine. And then just a couple of components in my design that I've copied from the topic grid. So we've got the 7-segment driver, the synchronizer chain, and the level detector. Got all my internal signals right here that I will need. Oh, and also this part right here, this did fix that one issue. I'm the person with the timing. I hold that actually quite proudly, to be the first person in the history of Professor Tippin's VHDL class to have a timing issue. But this did fix it, putting the range in there. So such a simple problem. Moving on though, I got my port map for the 7-segment driver, called it player score driver. Actually, speaking of, I'm going to open up my block diagram. I was going to do that before. Oops. Actually had it on the... Alright, there we go. Okay, so player score driver, port map for my 7-segment. The P1 button sync and P2 button sync are port maps for the synchronizer chain. Chain size of 2, and then everything else is just... Everything else, async in is the P1 button, and then sync out is the P1 button sync to synchronize the input. Excuse me. And then right here I've got the port map for the 7-segment driver, clock, reset. Digit 3 and 2 are to P1, player 1. Digit 1 and 0 are to P2. The higher digit in each of them is for the 10th digit. Blank 3 through 0 are just connected to the enables. So yeah, that's that. And then moving on, the port map for that, P2 button, same as that, but with P2 button, synchronizes that. And then I have the pulse gen, P1 pulse gen and P2 pulse gen for the level detector port map to take this and turn it into a pulse instead of a level. And then here is my state register for my state machine. And that's just simple state register. If reset is active, then the current state is going to be enabled. And when the rising edge of the clock comes, the current state is next state. Or the current state will be set to the next state. Yeah. And here is my state machine. I called it button enable, and it keeps track of a bunch of signals, and it'll change states depending on which signal is active and when. Alright, and it also detects bad button press. I'll go through it. So here's some default values I set up since this is asynchronous. So these are the signals that it's outputting: P1 button press, P2 button press, P1 bad press, and P2 bad press. Those are the signals that are outputted from the state machine. So here I have a case statement, and first case is enabled, so when it's enabled everything is not active, and it like looks through the signals. So if when detected is active, then the next state is going to be when, and if P1 button enable is active, so if it detects a P1 button push, P1 button enable is going to be coming from the pulse gen right here, the level detector from both of them. So if P1 button enable is active, then it'll check to see if the end detected is active or not, or if it's not active. And if it isn't active, then it's a good press. But if it is active, then it's a bad press, because that means that the round had already ended and this person pushed a button, so that's a bad press, which means they did an overlap. And the same goes for the P2 button enable, P2 good press, P2 bad press, and if none of those are true, then it'll just go back into enabled. Here we have our when state. Nothing is active and the next state is when. The only way to escape this is to reset. P1 good press, everything is not active except for the P1 button press, and then the next state is enabled. So it goes in, activates P1 button press, the next clock cycle goes out. Same thing goes for P2 good press, except with the P2 button press. In hindsight, I should have switched these to kind of easy, because I had P1 button press, P2 button press, but then I put P2 on top. I mean, it's all correct, it's just improved readability. But yeah, I've already saved and run the simulation. So P2 button press is active, next state is enabled. Same thing, goes in, enables the button press, and then it goes back to enabled, and then enabled, they're all set to low. So P1 and P2 button press will just pulse whenever there's a button. And same goes for the bad presses. So if there's a bad press and it goes active, then the next state is not enabled. And in not enabled, everything is set to not active, and the only way to escape is when round end is active, and we'll get to that later on, but round end will be active 1 second after the round ends, or after end detected goes high. So as soon as round end comes in, it'll go into enabled, but if not, it'll stay in not enabled. So that's that, and the same goes for P2 bad press. It'll send P2 that state, in that state P2 bad press will be high and everything else will be low. And then it'll go into not enabled, and the only way to escape not enabled is for the round to end, and then it'll go back into enabled right here where it'll do all that. Excuse me. Alright, moving on to P1 count. This is going to keep track of the P1 count integer. This is like the round point for player 1, like how many points he has scored for that round. Sorry, excuse me. So if reset is active, then P1 count is set to 0, and during the rising edge of the clock, if round end is active, then it's set to 0. Or else if a P1 button press is active, which comes from the state machine, then it'll increment P1 count. And that's that. And the same goes for P2 count. Same exact process except with P2 count, not P1 count. And that's that. And then in round end detect, if reset is active, then end detected is set to not active, or else if there's a rising edge of the clock and then round end comes in, then end detected is not active. This is to set that end detected low after the round ends. Else, P1 count plus P2 count, if P1 count and P2 count are greater than or equal to 16, then end detected is set to active. This is what's going to determine the end of the round, and then once end detected is active, if they push the button, then it's a bad press, and then 1 second after this goes high, this will go high, and once that goes high, it'll go low again. Round end timer. Alright, so here's where I use one instance of the count 100 megahertz. I'm pretty sure I use it in another timer as well. I got 3 timers in my code, but we'll get to those eventually. So this is your traditional timer, except with one change. I have if end detected is active, then it starts incrementing count. So once end detected goes active, count will keep being incremented until it equals 100 megahertz, which will happen in 1 second. And once it reaches 100 megahertz, it'll send round end high. It'll come over here, put count to 0, and then round end will be put to low again. And then reset, round end is not active and count is 0. That's standard procedure. But yeah, ordinary timer except with the end detected. Moving forward, our LED driver, where I have 3 internal variables, and these variables are as follows: P1 pattern, P2 pattern, P1 loop, and P2 loop. I originally had this set up as the for loop of the in-class example we had gone through. This was before we found out about the error with the constant, or with like that it needs to be constant. But so then I had to change it because I had gotten that same error, so then I changed it away from a for loop into this. So if reset is active, then LEDs are all off, P1 and P2 pattern are all off, and P1 loop and P2 loop are 0. Else, when the rising edge of the clock comes, if round end is active, then ditto with these. The variables are all set to low. Else, if P1 count is not equal to 0, then if P1 loop is less than P1 count, so whatever P1 count is, then P1 pattern is active and P1 pattern 15 down to 0, P1 loop gets incremented by 1. End if, and then the same thing with P2 count, and it'll go all end if, and then LEDs is P1 pattern or P2 pattern. This is what drives the LEDs, so when P1 count is like 1, it'll come here as long as it's not 0, it'll come here, P1 loop less than P1 count, which it will be, because it's either the beginning of the round, or like the reset is active, or P1 count just got incremented. P1 loop less than P1 count, then P1 pattern is active. So that's the shift register, and that's how we do the LED driver. I'm pretty sure we did this. Yeah, this was also in like the for loop, so I kept that part. I just got rid of the for and placed it with ifs and added this variable, or these two variables. Wrong way. But yeah, that's my LED driver. Same thing goes for P2 count, except with P2 loop and P2 pattern and stuff like that. And then they get ORed to make the LEDs. And that's it for my LED driver. Round points is a conditional signal assignment. So when P1 count is greater than P2 count, then round points is P1 count minus 8. Or else if it's the other way around, then round points is P2 count minus 8. But if they're equal to each other, then it's 0. So the only way they're going to be equal to each other is if both parties press it 8 times, and the round point would just be 0. So if they reach a tie, then nobody gets any points, or they get 0 points. But moving on, we got bad press detect. So this is synchronous, uses reset and clock. So if reset is active, bad press detected goes low. Standard procedure. Else if rising edge of the clock, then it checks if P1 bad press or P2 bad press are active, and if either of them are active, then bad press goes high. Or else when round end is active, then it goes low. So if it goes high, it doesn't go low until the round ends. And that's that. Moving forward, score enable. This was one of my trickier blocks. I wish I could zoom out a bit, but I cannot. I'm just going to move this over. I don't need that. So, score enable. I have this variable pulse signal in here. I'll explain what that does shortly. So if reset is active, all the outputs are set to low, as long as with the as is the variable, the internal variable. Or else rising of the clock, I got some default values. And then it checks the bad presses first. So if P1 bad press is active, then it checks if P1 count is greater than P2 count. I added this if right here because like I had this scenario where if one person wins and then the other person was losing, and I think the person losing did like a bad press, then it would still decrement them, even though they didn't even have any points added on, so they would just go backwards, and I didn't want that because that's not how the game works. So I had to add this so that it would only send these two signals when the person who presses like badly is actually the one winning. Moving forward, yeah, so P1 bad press is active, then it checks to see if P1 count is greater than P2 count. If it is, P2 update score enable goes high, and P1 bad score enable goes high. Bad score, well, actually I'll get into these in a minute. It's literally the block right after this, what these signals do. So just for now, that one goes high and that one goes high. P2 update score and P1 bad score goes high. And same thing with P2 bad press, except it checks if P1 count is less than P2 count, or P2 count is greater than P1 count. Same thing. And it'll send P1 update score high and P2 bad score high instead of like that way. And if there are no bad presses, Excuse me, I hope you didn't hear that. Then it checks to see which player has a greater score. And yeah, pulse signal, the internal variable goes high when update signals are sent. So if end detected is active and bad press detected is not active, this is to make sure that there are no bad presses. Then this is the internal variable. If pulse signal is not active, then it'll check which person is greater. P1 count is greater than P2 count. If that's true, then it'll update P1. If it's not true, then it'll update P2. But in both cases, pulse signal is set active, and this is so that this signal itself, when it goes forward, it only pulses once, and then it only increments the person's score once instead of multiple times. So if like the total round points were 2, and the person who like won that round gets 2 added, if I didn't have this signal and it kept going through this if statement each clock cycle, it would keep adding 2 and 2 and 2 and 2 and 2, and it was Bad Times at the El Royale, which is a great movie if you have not seen it. But moving forward, so that's if pulse signal is not active, or else they're both set to low, so this will pulse the signal as I said, and then pulse signal is set low when the round ends. So it'll just update the score, and then it'll stay active until the round ends. The pulse signal will. And yeah, that was my. Oops, I had some bubble wrap accidentally popped. Got a little scared. All right, so that was my score enable block, not driver. But yeah, that just went through, checks all the bad press or good press or bad press or like not bad press signals, and has like 4 other signals that it sends along the way that we're going to get to next. Those signals come into these blocks right here. P1 score. So the way P1 score works is if reset is active, then P1 score is 0, or else when the rising edge comes, if P1 update score is active, then it'll increment P1 score by the round points, which are the total points for that round of like whoever went over 8 LEDs. Or else if bad score enable is active, then it would take away those points. So basically, say somebody gets 14 LEDs and the other person gets 2. The 14 LEDs score would go up by 6. So yeah, that goes up by 6 because the update score comes in immediately. And detected goes high. Bad press is still low because no one's had a bad press yet. Pulse signal is not high. So then the update score would come in. It would update their score right here. But then say they accidentally hit the button again, and they go to a bad press. What the bad press does now is it'll detect that P1 bad press is active, and P1 count is greater than P2 count because it's 14 to 2. So then it'll send P2 update score high and P1 bad score high. And P1 bad score coming high, it takes away the 6 points they just earned. And then P2 update score going high gives the 6 points to P2. So it's actually kind of funny. You'll see it in the next video when I show you on the board, but like when the person who wins, their score gets updated immediately, and then the game waits a second until the next round starts, and in that second, if they press the button again and make a bad score, then you can see their scores switch, or not their score switch, but like the round points switch. So it would be kind of funny if like somebody was on the brink of winning and then they have a bad press. They can watch as their score falls, and you can see their soul get sucked out of their body. But moving on, same thing happens with P2 score right here. It checks if update score is active. If it is, it'll increment. Bad score is active. If it is, then it'll decrement. And that's the reason why I had I went over this. That's the reason why I had this in here, is because I didn't want it decrementing when it had never been incremented. So yeah, that was the score blocks and the score enable. And the BCD converts are BCD converts. They're just what they are. 2 variables, first digit and second digit. You do the modulo operator to get the first digit. You do dividing to get the second digit, both by 10. And then you get P1 tens and then P1's digit just by standard numeric package, doing the standard logic vector 2 unsigned, second digit 4. That's same case for P2 BCD convert. It just converts their scores into BCD, binary something decimal. I forgot what the C was. But moving forward, win detect. So this is asynchronous. It just checks P1 score and P2 score. And here's some default values. So possible win is not active, P2 wins is not active, and P2 wins is not active. I think I said P2 wins twice, but P1 wins and P2 wins. Then it'll check to see if P1 score is greater than or equal to 21, and if it is, then possible win goes that high, and P1 wins goes high. Or else if it isn't, and P2 score is greater than or equal to 21, then possible win goes high, and P2 wins goes high. Or else if neither of them are, then it won't do anything. These will stay low. And then the win time base. So here's my other time base, which uses the count 100 megahertz. So basically almost like your regular one, except with the possible win. So when the possible win comes in, it'll wait a second before sending the win detected high. The win detected will it'll stop all the buttons. So once win detected goes high, the button inputs aren't read anymore. So it waits a second in case there's a bad press. So possible win will go high, and then it'll wait a second, and as long as there are no bad presses, aka like the scores don't get decremented, and then so like if the person goes lower than 21 again, then win detected will go high. But if it does, that's why it waits a second. And yeah, so if possible win is active, then that, or else if it isn't, then count is 0. That's so like possible win is high, it'll start incrementing, and then if it goes low again, like if the person did a bad press, then count will be reverted back to 0. So that way the next time possible win is high again, there will be a second, not lower than a second, till count reaches count 100 megahertz. And then here we update the signal. There's no win detected is not active beforehand because I don't want it to pulse. I want it to just stay high as soon as it reaches count 100 megahertz, or as soon as it goes past a second. So that'll go high, and then count will stay 0. This is just to keep it in that range of 0 to count 100 megahertz, because if possible win is active, then it'll keep incrementing as long as it isn't 100 megahertz. And yeah. So moving on. Right. So we got the blank time base. This one uses the count 25 megahertz, so the quarter second. And if reset is active, count is 0, and flash enable is low. Or else if when the clock edge comes, it checks if win detected is active. Win detected will be active 1 second after possible win. So once win detected goes active, every quarter second this will send out a flash enable pulse, not a level signal, just a pulse. So 1 clock cycle this will go high, and then it'll go low. Wait a quarter second, go high, go low. Wait a quarter second, go high, go low. This is, yeah, the only change I made with the regular like time base would be the win detected. And then here we have my blinking driver, something that gave me this, and the score enable gave me the most problems. But yeah, I got 2 variables, internal variables, already changed and blank state. So when reset is active, everything is set to high. That's because the blanks are active low, so they're set to high, so they're not active. And then already changed is set to high, and I'll explain that in a minute. Blank state is set to low. And then when the rising edge clock comes, it checks if flash enable is active. So if that pulse is active, blank state is set to the opposite. So if it's high, it'll be set low. If it's low, it'll be set high. And no matter what already changed is, it'll be set low. So if blank state is active, then it'll check if already changed is not active or low. And if both of those are true, then already changed will be set high, and it'll check which player won. So if P1 won, then it'll invert P1, the player 1's digits, or the blanks. Or else if P2 won, then it'll invert the P2 blanks, player 2 blanks, or player 2's digits on the 7-segment driver. And so once already changed is active, it'll stay active up until flash enable comes in again. So flash enable will come in, change it to low, but when it does that, it'll also change blank state to the opposite. So if blank state was active, then it'll change it to not active, and then it'll skip that. So it won't invert. It won't keep like inverting it. I feel like I did kind of a bad job explaining that. I'll do that one again. But moving on to the next, like after the if blank state else, it'll just checks if P1 tens digit is 0. If it is, then it'll get rid of the 0 digit, the leading 0, or else it'll just have them both visible. And the same thing with P2 tens digit. If the P2 tens digit is 0, then it'll get rid of the leading 0, or else it'll have them both showing. But let me try and explain this a little bit better. So basically, let me go through a scenario, and I'll have it on my phone. So reset goes high, already changed, and hold up, let me write this down. Changed and blank state are currently changed is active, blank state is not active. So then flash enable comes in whenever the game is won and the person scores to be blinking, and it'll change blank state to active because it was just not active, and already changed will be set to not active. So because blank state is active and already changed is not active, it'll then invert whichever player won, it'll invert their blanking. And then after that, already changed will be active. So that'll go to active. And now because it's active, it won't invert their thing again in the next clock cycle, because this goes through every clock cycle. So it'll invert it once, it'll come back through, and it'll fail this if statement, so it won't invert it again. And then it won't do any of this because if blank is active will be true. So it'll only look at this block. So it'll be true over here, it'll be false over here, and then it'll move on to the next clock cycle. It'll just keep doing that over and over again until flash enable comes in again after the quarter second. And blank state will be set to not active because it was just active, and already changed is set to not active. And because blank state is not active, it'll move on to this block where it'll show all the scores, or it'll show like the scores in general, and it'll keep doing that every clock cycle until flash enable is active again. And when flash enable is active, blank enable goes to high because it was just low, and already changed goes to low. Well, I mean it was already low, but it won't change basically. And then because of that, it'll go through this block. It'll change it once. It'll invert whoever won. It'll invert their blank, so they'll be shut off. And then this will go high. And because it'll go high, it won't turn their thing back on. And it'll just keep doing that and just keep looping like that over and over again. A little bit tricky to figure out. I had it at first. I added the already changed variable because I had just a blank state at first. But every time flash enable came in, it would still like keep looping through here. So the score would be showing the entire time, but you could see it like fading in and out just a little every quarter second, and we wanted to shut off completely. Shut off and shut on, shut off and shut on, stuff like that. So that's why I had the already changed as active. And yeah, well that's my code in general. I will now go through the test bench code. I do believe I covered everything in here. That's surprising. Just adding the components, the internal signals, and then port mapping brings you almost halfway. I'll go to line 200 and there's 600. It brings you a third of the way there. I thought there were 500. Either way, I did go through everything, I believe, yes. And oh yeah, that timing issue. Funny thing, when I was synthesizing and implementing it before, it was at like 2,000 and 3,000 lookup tables. Now it's at 300, so it definitely saved a lot. Just that one simple error with the integer value or the range. But yeah, I did go through all of it. The time bases, I had 3 of those. There's win detect. Yep, score enable. I went through that. Okay. I feel like I explained pulse signal correctly all the way. So this basically just sets them high once during the round. If like there's a good press, it'll only set it high once. Because I had it I had it like at one point when there was a bad press, it would increment one person's score twice, and it would increment the other person's score also. It was weird. There was a weird scenario, which is why I had the pulse signal placed in there, so that it would only send these signals high once in this if block. If there's a bad press, then it'll send the other ones high if that person's leading. But yeah, that was my code for the BuilderGame component. I'm gonna go through the test bench now. But before I do that, I'm gonna grab a water bottle. I don't have one near me. I'll be not even 5 seconds, 1 second. Alright, I don't think that was 1 second, but I definitely moved quick. Excuse me. I apologize if you heard me drinking. But moving on to the test bench component, I just supply certain button inputs to determine correct performance of the LEDs in 7 segment. So obviously there's no ports for a test bench. Got the active signal right here, and then we have, moving into the architecture, we have the active signal. We've got the BuilderGame component. We've got some signals right here: left button, right button, down button, clock, segments, anodes, and LEDs, which are self-explanatory. And then right here we begin. Our unit under test is the BuilderGame, so we port map that with our signals that we just set right here. So clock is clock, reset is the down button, P1 button is the left button, and P2 button is the right button. LEDs, segments, and anodes are their respective selves. So the system clock, usually I know we do 5 nanoseconds if we want to simulate real time, 100 megahertz clock period, or 100 megahertz clock. But I did once 1 nanosecond wait and 1 nanosecond, so I did 2 nanoseconds for a clock period. So that's a 500 megahertz clock right there for the test bench. And then reset, the system reset, it just activates down button for 2 nanoseconds and it just lets it go after that. And here we have our button driver. So in my test bench, I simulate an entire match in 1.5 seconds, and the next, all of the code is just a bunch of button inputs. But instead of going through each individual one, like left button goes high, right button goes high, left button goes, like instead of doing that, I'll show you the rounds, but I'll tell you what happens in each round. So for the first round, left and right will alternate, with the left overrunning. So left will go up to 10 LEDs, right will go up to 6, and then left will overrun onto the right side. So that's what happens right here. They're not active, and then they wait, and then they start pushing the buttons right here. And here's where the left button overruns on the right button. Then we wait 200 milliseconds for the round end signal to go high. Usually it'll be 1 second, but since we're running at a 500 megahertz clock, it'll be a fifth of a second, which is 200 milliseconds. And then we move on to our second round, which has left going all the way and then overrunning at the end. So what that means is left goes 16 LEDs and then it'll overrun right at the end. So just a bunch of left button is active, and right here it overruns. And then we wait another 200 milliseconds, and then we move on to our third round, where the first 2 buttons are at the same time. So this is to like simulate 2 people pushing the button at the same time. One thing I did, what do you call it? I did notice, because I had these actually activating at the exact same time at first, like left button's active, right button's active, then it would wait. If left button and right button go active in the same clock cycle, then one of them won't be counted. Since the odds of that are so small, I don't think I really have to worry about it in my code. But this is to simulate like how it would happen in real life. So like if people press the button 5 nanoseconds within each other, then that's like kind of crazy in and of itself. But even that's like really hard, like not likely to happen. But yeah, this is that happening right here. So left button goes active, it'll wait, then right button will go active, then it'll wait and set both of them not active. But yeah, so the first two are at the same time, and then right will overrun at the end. So the left signal will go 12 times, 12 LEDs, and the right one will go 4 LEDs, overrunning with the fifth one. This round was this round showed me like to add, where is it? That's the round that showed me I had to add this into my code. Oop, I passed it right here. This, because that's wrong tab. Because right is technically losing. He's only got 4 LEDs and left has 12 LEDs. But since he had a bad press, it would still decrement him, even though he never got the round points added on. So I had to add that little if block to make sure that wouldn't happen. And then the fourth round, right goes the entire way, no overruns. He just goes all 16, and that's it. No overrunning. And then fifth round, right overruns after alternating. So it's basically like the inverse of the third round. The left LED will go 5, and the right LED will go 11, and then overrun on the 12th. Excuse me. And then the sixth and final round right here, right takes it home with just activating all 16 of them. And yeah, those are all my rounds. And then after that, the final score should be 7-26. I never actually had those written down. I probably should have. But either way, first round, the final score after this would have been 0-2, with left being 0. And then after the second round, the final score would have been 0-10, with right having 10. After the third round, where is it? Right here. The final score would have been 4-10, with left getting 4 added to it because right would overrun. Well, not because right would overrun. Right overruns, but it doesn't get, like, left was already winning in the first place. With first and second round, left overran, which gave right the scores, or the points. And then fourth round, I have right taking it all the way, so it gets 8 added to it, so the score will be 4-18. Fifth round, we have 7-18, because left will, I'm sorry, not left, right will overrun, so it'll give left the points. So that's what this one was, 4-18, and now it's 7-18. And then in the sixth round, right takes it all the way, so he gets 8 more points, making it 7-26, and that's when the match is over. So now I will show that in the simulation. I'm going to go all the way here to the beginning, zoom in really deep into it, since I did have like all the buttons being pushed right at the beginning. So yeah, I added all these P1 button sync, P2 button enable, and the button presses. I added them signals because I was trying to figure out why the board was incrementing multiple times sometimes when I pushed, which today in class we discussed it was the debouncing. But excuse me, let me just drink some water. But yeah, so those weren't even an issue, but I won't really be focusing on them too much. Because you can see here, left button goes up by 4, and here's the left count, 0, 1, 2, 3, 4, right there, right after that button press right there. The next clock cycle, this gets incremented to 4. Right goes up by 2, so right there, goes up by 1 in the next clock cycle, and then it'll go 2, and then left will go up by 1, it'll go up by 1 right there. So because this is like the giving instructions for like the next clock cycle. So then it'll go up right there, and in the next clock cycle it'll increment to 5. But while it's incrementing to 5, the right button gets activated. So then in the next clock cycle this goes up to 3, and yeah, they just keep doing that. You can see them going up. So this goes all the way up to 4, then 2 right there, add another one right there to go to 4 to 5. I was realizing that saying right there isn't very helpful. But yeah, now right's at 2, and then it gets another button press, so it goes 2 to 3. It'll stay 3 for a while because now left's pushing. like with the test bench code. So left goes up 4. It was already at 5, and now it gets 4 more pushes. So it goes 5, 6, 7, 8, 9 right there, or right at this point. And then, give me 1 second. I'm getting a call. Sorry about that. I do apologize. But moving on, you can see the buttons. With each button push, the counts are being incremented correctly. And as the counts are being incremented, round points is being incremented. So it just sees who's in the lead, and it'll just increment based on whoever it is. So now, who's in the left is in the lead. They've got 10. So right there, round points is now 2, because 10 minus 8 is 2. And then with that, as soon as it reaches 10 to 6, end detected goes high, because the total round count, P1 count plus P2 count, is greater than or equal to 16, which it is. And with end detected going high, you can see right there that left button gets pushed, so that's a bad press right there. And you can see that gets detected right there with the bad press detected, and I had the bad press some way here. Right there, P1 bad press. So that's right there. You can see that gets set high right there with the left button getting pushed. There. Sorry, I was just so off. Like the zooming in and out. So P1 bad press goes high. Oop. P1 bad press goes high, and then the next clock cycle bad press gets detected. And because bad press got detected, you can see right here that P2 update scores got set high, and P1 bad score got set high. So right, I forgot to do this, but when end detected went high, 1 clock cycle later, P1 update score went high, so P1 score went from 0 to 2. But then they did a bad press right here. P1 bad press gets detected, and then the P2 update score is high and P1 bad score is high. Bad score takes the 2 and it decrements it. It'll take P1 score and it'll decrement it by whatever the round points was. So round points is 2, so 2 minus 2 is 0. So P1 score is 0 again, and P2 score it gets incremented by the round points because P2 score update score enable goes high. So 0 plus 2 is 2. So that works as it should. Person in the lead overran, so their scores get, their points get transferred. And oh yeah, you can see that in the, here I'll show the state machine as well in work. Okay, I'm going a little further back. Wow. Start from right there. So you can see P1 good press, P1 good press. I'll have to call them back. So P1 good presses. Why is it not? There we go. P1 good presses enabled. P1 good presses enabled. P1 good presses enabled. Give me 1 second. So sorry about that. It was my mom, and she's out of country, so I had to let her know. Either way, P1 good press, P2 good press. You can see it's all good presses right up until you get the bad press right there. So enabled, and then as soon as it senses the bad press, it goes into not enabled. The not enabled state will not read any more of the presses. So after one person gets a bad press, then another person can't, it won't like keep switching score points like that, because that'd be dumb. But Yep, you can see the blanks are working correctly. Right now, they're at first the scores were 0, and then it became 2. By the way, there's no tens digit, so the leading zeros are not showing, as the blanks are high because they're active low. But yeah, that was the first round. Oh right, the LEDs. Let me show that. So you can see that working right there. I can take this out. So the left gets +4, and then right gets 2, left gets 1 more, right gets 1 more, left gets 4 more, right gets 2 more, left gets 1 more, right gets 1 more. You can see it going up with the button pushes. If I do that and then zoom out a bit, yep, so left went up, 1 clock cycle after that, left one went up. So the LEDs are working correctly as they should be. Detected, yep. The tens digit and the blanks, current state, yeah, everything's working right. That right up there's the clock. I don't know why I pointed that out. But that was the first round. Oop, went really far out. Then we've got our second round right here. I can show the round end signal, which comes in right there. Round end comes in. It'll take P1 count and P2 count, set them both to 0. Sorry, I have to drink some water. P1 count, P2 count, set both to 0. LEDs are set to 0, or none of them are on, and round points is set to 0. Scores stay as is because the match isn't over yet. And then the buttons get activated. So on the second round, the left person was activating all of them, and then they overran right at the end. So you can see that right there. The left button just keeps getting pushed, and then they get a back press. So I can show that working right there. You can see P1 count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And you can also see the LEDs working right as well. So they just keep on getting activated right up until the last one is, because of the left buttons being pushed. So let me scooch over to the end of the round, or end of the button pushes, and you can see right when the last button is pushed, P1 update scores set high, so it'll go from 0 to 8. But then it does a bad press right there. That was a bad press, and 1 clock cycle it'll detect that right there. So bad press gets set high. The bad press is detected, and when that's detected and end-to-end detector is also high, and that's high, it'll set P2 up. It'll set the opposite player's update enable score high, and the person who overran their bad score enable goes high. And so that what that does is takes 8 and it subtracts it again, because they had 0 at first, and they got 8 points for that round, and then they did a bad press, so they got it taken away. And the other person had 2, they get 8 points because the other person overran, and they get 2 plus 8, 10. So now their score for the round is 10. So P1 is 0, P2 is 10. P1 feels bad. P2's he's high as a kite right now. And yeah, that's all working. States are basically the same as they were in the previous round, with all the good presses and the bad press coming in and making it not enabled. You can see all the good presses going in. I won't get into all of them. Oops, I zoomed in way too far. Oh, and right here you can see the blanking driver working. So as you can see right there, P2 score gets set to 10, so now the leading 0 is, well, there is no more leading 0. So right there, blank 1 enable is set low. So now you can see the 1. And yeah, you can see that right there. P2 tens digit is 1, and since that's no longer 0, blank 1 enable is low. And since they're active low, you'll see it now. Oh, you can also, that person right there, look at them, they feel so bad. P1 1 digit goes to 8 and then it goes to 0 again. Either way, moving forward, that was the end of that round. Or, that was the end of that point. Or the button pushes, sorry. This is the end of the round itself. So right here we have our third round of button mashing. So in this round, left went 12, right went 4, and then right overran the 5th. So you can see that right here. Right went 4 first, and then 12 goes left. Left goes 12, and then right overruns right there. So right, you can see detected goes high right there, and P1 update score is set high, so P1 score goes from 0 to 4, since 12 minus 8 is 4. And yeah, so but then it detects the bad press. So P2 does have a bad press, and bad press gets set high, and then detected as high. But the reason why P2 update or P1 update score and P2 bad press aren't high like in the other button pushes is because the person who did the overrunning was losing. So we don't want to take away their points since they never gained any to begin with. So this was like the part where I realized I had to add that bit of the code. So yeah, that explains that. And right here, everything's just that one's still 10, the person's still 4. Blankings are as they should be. The those are the state machine is as it should be. It detects a bad press, goes into not enabled, and the well, I'm supposed to take a look at the segments as well. The segments are very far spread apart. I will show them in a second. Segments, and then the anodes as well is all the way down here. Anodes are E right now. They alternate. They're in the 7-segment driver. They're already predefined or like pre-coded before I touched them and messed them up. But yeah, that was the third set of button pushes. So right now, this from here to here is the third round. So the buttons get pushed, state machines are not enabled, it's waiting for the round to end, and then when round end goes high, which is this signal right here, it'll go high right there. Then the state machine will go back into enabled, and the rounds will start again, and we'll start incrementing again. So right here we have our 4th round beginning. Excuse me. So, 4th round. The right person takes it all the way, all 16. They don't overrun at all. They just get 16 straight up. So you can see that right there. They get all 16. Boop, bop, beep, beep, bop. P2 count goes up 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 right there, right after their last button push. You can see that. And then right after that, their LEDs all go on. You can see those in action as well. I never showed them from this side. So as right keeps pushing the buttons, the LEDs keep getting turned on and on and on until they're all on. And here, right there, they're all on now. So the LEDs are working correctly. P2 update score goes high since the round has ended. It goes high, it gets incremented by 8, so it was 10, now it's 18. And there's no bad presses, so bad press detected doesn't go high, the bad scores don't go high, nothing else goes high. Nobody gets their points taken away this time. So just a regular old round. You can see right here, it's the state machine stays in the enabled state. In case somebody does give it a bad press, then it'll show a PX bad press, whichever person pressed it, and then it'll go to not enabled. So yeah, that was just a regular old round right there. Nothing too crazy happened. The left button player, he was snoozing, so right person took advantage of that. And yeah, that stays like that until you get to the end of that round. So that round will last from there to there, way over here. Oh, I'm clicking the wrong button. Sorry. Alright. There we go. So now we are, round end goes high right there. And now the counts are put back to 0. Oh, this one was already 0. This one goes to 0. The buttons get pushed. This is the 5th round. So left person pushes it 5 times, right person pushes it 12 times or 11 times, and then overruns the 12th. Excuse me. And you can see that working right over here. We come over here. P2 count is 11, and you can see P2 update goes high. The score gets incremented by 3. Oops. Right there, 18 plus 3, 21. So they were winning, and if they had left it alone, they would have won. You can see right here, possible win went up by 1, and P2 wins went up by 1, right up until the bad press came in and just ruined his day. He had a bad press. Next clock cycle comes in, P1 update score goes high, P2 bad score goes enable goes high. They take the 3 away from him. They up P1 score by 3, so the 4 goes to 7. The 21 goes back to 18. The possible win goes low, and the P2 wins goes low. And the match carries on, all because he just couldn't control himself. Feels bad. But yeah, that's you can see this. The digits are working as they should be, and blanks are still good. The first one's still high because player 1 still hasn't gotten out of the 1's digit range yet. He's striving. He's trying. But yeah, that was that round, 18-7. That'll explain why you see 18, and then instead of like continuing with 18, it like crosses, because it actually went to 21, just for a smidget there, until he lost it. So that was that round. You can see all that working correctly as it should be. LEDs work. I can show them in action. So, whatchamacallit. You can see left button, then right button, then left button, then right button, then left button, then right button, then left, then right, then left, then right, all the way, and then he overruns. But that doesn't obviously show on the LEDs. There's only 16, not 17. Excuse me. Let me close that. So that was the 5th round. That was the 5th round button push. So the 5th round will carry on right up until here. Yeah. So 5th round, and then round end goes high. 1, 2, 3, 4, 5. Yep. Sorry, just had to double check, make sure of everything. So now we are, 5th round has just ended, the round end has just gone high, 5th round has ended, 6th round has started. Oops, I meant to do this. So if you hold shift and use the scroll wheel, it takes you side to side, and control in the scroll wheel zooms you in and out. So I learned the shift part. I really enjoyed it, because every time I use this thing, it'll just fly me all the way across the simulation. But 6th round, right person just takes it home. He goes all 16 and he doesn't overrun. He learned his lesson the previous round, and he just decides, he's like, you know what, I'm better than that. I shouldn't overrun this time. So his count goes from 0 all the way to 16. 16 next clock cycle, and detected goes high, and detected goes high. It updates his score. His score goes from 18 to 26, and it stays there as well. 26, and you can see right there, possible win is high, and P2 wins is high. You know, he's flying over the moon right now. He's ecstatic. You know, he just won a bet. I don't know, but that works as it should. The LEDs are working as they should. I can show them right here. Right person just takes it home all the way. You can see that clear as day, or clear as green. I don't know why I said that. That wasn't even a good joke. But yeah, P2 good presses all the way, and then it stays enabled, and there still could be a bad press. The buttons aren't inhibited yet. I don't know why my voice is cracked, but they're not. The win detector hasn't gone high, so people could still press the button. He could still press it and have a bad press for 1 second after this. But after that second, you'll see it right here. 1 second later, or 200 milliseconds, right here when round end goes high again. Boop. You can see when detected goes high. Let me zoom in. So possible win's been high for 1 second or 200 milliseconds with the 500 megahertz clock. And then win detected goes high, and then the state will go into win, and no more buttons are allowed to be pushed. So no matter how much they try, they can't push them anymore. And his is locked 26. The round points are 0 again because the round end is active, but that doesn't really matter. The match is over. The counts go to 0, but the match is over. LEDs go to 0. Match is over, man. What are you gonna do? 7 to 26 is the final score. And right here you can see as soon as win detected goes high, every quarter second or 50 milliseconds for the 500 megahertz clock, you can see flash enables going high. So when the win detected went high at 1200, flash enable goes high at 1250, at 1300, 1350, 1400, and 1450. And each time it goes high, the blank 1 and blank 0 enable, or the digits that for the 26 right here, P2 and P1's 10 digit, those two digits are flashing off, on, off, on, off. And yeah, everything's working perfectly fine. That's match over. Okay, game is done, everybody's done. That's the end of the simulation. This part was a little tricky. So what I was referencing with the reason I had to add the already changed was because sometimes, not sometimes, when it was only blank state and it would go high, every clock cycle within here, it would go high, go low, go high, go low, go high, go low, go high. So it wouldn't actually turn off. You could still see the number, but you could see it pulsing brighter every quarter second. It would go brighter, lower, brighter, lower, brighter, lower. But I needed it to go off, on, off, on. So that's the reason I had to add the already changed variable. So yeah, that's the game. He's in the win state. The only way to get out of the win state now is to reset it, and once you reset it, the scores are 0. State machine goes back to enabled. All these signals go back to low, and it's just a fresh slate, clean slate. Start from there again. So yeah, that's been my simulation for the BuilderGame component that I have built. And well, yeah, I don't really think there's anything else to add on to this. I'm already over an hour, so wow. I wonder how long my project video is going to be. But yeah, that's been the BuilderGame. Been a very interesting experience, timing problems, state machines, I learned a lot, panicked a lot, but we got there in the end. We got there, the debouncing is a little, the bouncing of the switches on the board is a little annoying, but at least I know the simulation is working perfectly fine, and that the component actually is properly working. I'm sure it can be more efficient. I'm basically 100% positive that, everything I make, I'm sure can be more efficient, but it works perfectly, and I'm quite pleased with it. I hope you are too, as my grade depends on it. I'm just playing. But yeah, that's been my BuilderGame component, or the code video, and I'll see you in the next video where I implement it on the board, and you'll see it working real life. Alright, that's the end of this video. Have a great rest of your day, rest of your evening, rest of the night, whatever rest of the day works, I suppose, or week, whichever, potato. Bye-bye.